Welcome to Calculus for Us. In this video we will be learning how to use the trapezium rule. The trapezium rule is an alternative method to find the area under a curve. So you could either integrate a function or you could use the trapezium rule. Now the trapezium rule will give you an estimate, unlike just integrating and then putting in the values a and b, then subtracting them from each other. That will give you, the real area underneath the curve. The trapezium rule will give you an estimate. So this is the trapezium rule. It's a half multiplied by h, open brackets. So the first strip plus the last strip plus 2 multiplied by all the other strips in between. Then you close all of your brackets. Okay? In this case, h is equal to b minus a over n being the number of strips and a and b being your two borders. So if you want to find the area between those 2 points, that will be your a and your b. H is the width of the strip. Okay, so now that you've established that, I do have to state that when you do a trapezium rule question, you have to be very careful with this value here and the number of strips, because for example, if I am to show you here question, here you will be required to find h. So what is h? And so it may appear that you've got, 1, 2, 3, 4, 5 values, but n is not 5, n is 4, because there's actually 4 strips. The way I like to do it, I like to go 1, 2, 3, 4. So you've got 4, so n is 4. Okay, so now let's try and do this question. Of course, using the trapezium rule. This rule right here. It's very, very long and tedious. And just to state, what this rule does as well is, the reason why it gives you an estimate is because you've got all these strips, and then what it does is it connects them to each other like this, so you won't end up being a curve. The more strips you have, the smoother the curve. But as you can see, it won't give you a smooth curve, and that's why it only gives an estimate, not the real value of the area under the curve. Okay, going back to the question, here we are. Part A asks us to, luckily for us they've already told us how many strips we have, but sometimes you will be asked to do that yourself. So they'll give you the two kind of values a and b, and they'll tell you you do this kind of chart yourself. Okay, so the first step is to make a chart in which they've already made for us, and they've asked us to fill in those values. What you have to do is take your value of x, in this case is 1, 1.25, 1.5, and tuck those into your function. Put those in and you will get, so if you put 1 in, you will get 4. Put 1.25 in, you will get 4.84. And if you put 1.5 into your function, you will get 7.06. Okay? Very easy, very simple. Shouldn't take you too long. Okay? Now, this is the bit where you have to use the extremely long trapezium rule. Okay? So, I'm going to do it on a new page, so you won't be able to see the chart, but you can, we'll go back to it when we do the rule. Okay, so, new page. Okay, so we've got our function with our boundaries. Okay, and we just have to use the trapezium rule now because we know what the values are between those two boundaries. Okay, so using the trapezium rule, as we said, h is equal to b minus a over n. So we did establish that n was, according to this, n was 1, 2, 3, 4. N was equal to 4, so we do 1.5 minus 0.5 over 4, which will give us 1 over 4, which is equal to h. Okay, so putting all of this into that big equation that we saw at the beginning, this one. Okay, oh, that's all you have to do, just put it in. It's 1 over 4 multiplied by half, open brackets. Your first function, your first number, your first value of y, which was 6.06, as we see here, there, plus your last value of x, which was, of y, sorry, 7.06, there again, see? And then we put all, and we do plus 2 multiplied by all the values in between, which I will put there. Of course, make sure we close all of our brackets. Now, chuck that all into your calculator and you should get one value. Okay, and that value is 4.93, and that's it. That is you using the trapezium rule to find an estimate to the area under a given curve.